Welcome to Blackhat Arsenal. In this presentation, we'll be discussing a tool which we guys wrote called Dejavu. Um, Dejavu is a deception platform through which you can deploy decoys at scale. And the reason we're calling this presentation Dejavu Plus Plus is we started this project back in 2018, and since then we've made a lot of progress, both in terms of features and architecture, and hence the name Dejavu Plus Plus. Now, coming to the agenda, um, we'll probably start with what deception is. I'm sure a lot of you out there already are aware of this, but we just want to set some context before we dive into the tool. We will then have a quick intro of Dejavu, what was our thought process while developing the platform, also a quick sort of feature set which is part of Dejavu, and then jump into our journey. So um, um, from 2018 till now, what were the various features added at various phases, and then look at a very high level architecture on the major components of the platform. Um, Once we've done all of this, we will quickly dive into the demo, which I think is the interesting part of the presentation. And the way we've laid out the demo is we will first look at the attack, and then look at, hey, how do we now um, detect this attack using deception? So that's the workflow we'll be using during our demos. Um, yeah, so probably before we dive into the presentation, just a quick intro about ourselves. My name is Harish. I'm based in Toronto. Mostly been doing offensive security and application security work. Um, Badrish, do you want to probably give a quick intro?
Hey guys, this is Badresh, just another ordinary guy, likes to code, break stuff, likes to play with controller. Yeah, and looking forward to this presentation.
Awesome. And guys, please feel free to reach us out, either on Twitter or on email if you have feedback or suggestions on how can we improve the platform. Um, so, so deception is not new. It has been used in the warfare and in other aspects um, of defense. Um, and even in cyberspace, it's not new, right? I mean, back in the days, we were using honeypots, but honeypots were primarily used for research and not for active defense. Um, with deception in today's world, although it's kind of a buzzword, but but now we could strategically use lures, breadcrumbs, and services to detect attackers at a very early stage. Um, so, in very simple language, they're traps to confuse and detect attacks. Um, the reason we believe deception is difficult to detect from an attacker point of view is it's very hard to to understand or to figure out what's a real service versus what's a fake service. If you look at these two screens, one is a real service, another is a fake. It's almost impossible to figure out. And so would the attacker. He would have to interact with it. He would have to enumerate. And while he's doing all this, there are logs being generated in the back end. Now, why deception, right? I mean, um, I think one of the fundamental problems with with today's infrastructure is networks are complex, right? And this makes attackers' life very easy. Once he's inside the network, because of the complexity, he's able to gain compromise in a matter of time. And we've seen this practically during our red teams as well. Getting in might be difficult, but once you're in, you could laterally move pretty easily. Also, a lot of solutions by nature have high false positive rate, and that's just because it's very difficult to make a real traffic versus attacker traffic. There are amazing solutions out there. So we have EDR, um, and the state of EDR has really improved. But even then, bypassing an EDR is is probably difficult now. But given enough time, you could bypass pretty much every EDR. Um, and what we observed is most solutions are not based on offensive thinking, and and when it comes to deception, deception is um, very much based on offensive thinking. Not just Dejavu, but just the nature of deception is 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 very offensive thinking, in my opinion. And deception solves this problem because of two main reasons. One is high accuracy. When you get an alert from a decoy, it's most likely a high accuracy or a high fidelity alert. No one would interact with the decoy except an attacker. So you most likely know that there is something happening on the network which is worth investigating. And the other reason is it's very difficult to detect, like I mentioned, because attacker has to move onto the network. He has to move inside the network. So he would have to enumerate. He would have to go around poke services. He would have to go fetch credentials from memory. And while he is doing all this, if you place your decoy strategically, he would interact with your decoys by just the nature of his movement. Um, Badresh, do you want to add anything here, or should we continue?
Yeah, I think we can continue. Basically, the next thing, the next thing that literally comes to our mind is like, what's there in Dejavu? Like there are so many tools out there. There was a honey, like there was the honeypot project. There are so many honeypot projects. What's there in Dejavu for us? So when we initially also started, which we'll cover in our subsequent slides, when we initially started the whole journey, we were kind of in a state where we were not able to find a platform, like a single platform from where we can kind of manage all the decoys slash honeypots, whatever we call it. So that was kind of a journey from where we started. And that's exactly what we can find in Dejavu. Like it is a single platform from where we can actually deploy, manage the all the deception across infrastructure, across the branches. It kind of takes almost like maybe like 7 to 10 minutes to kind of up and run the deception. And most important part here worth mentioning is that it doesn't really disrupt your existing network. Like while you are deploying a deception, it literally doesn't have to stop your like any services. It doesn't have to kind of change your network topology, etc. So it's very easy to deploy. It hardly takes like 10 minutes to get started. And recently, we have also kind of added the cloud capability so that you can actually deploy the decoys in your your AWS infrastructure. And we kind of invested a lot of time into making sure that the decoys are very highly interactive and kind of really engage the attacker and deviate him from the real target. We also added a couple of cool features like the evidences with full packet capture. We have the video recording of his activity onto the RDP decoys. He's like a complete command traces if this is an SSH decoy. Like so, we have kind of not just kept the decoy very highly interactive, but at the same time we try to add more evidential aspect of the whole platform so that you have right evidences to investigate or to do the forensic analysis. And above all this, there is a centralized dashboard which can be used for the monitoring and analysis. and like give you a full life cycle and of the event. You can manage the full event from that particular dashboard, which is quite useful. If you are an MSSP or a SOC, you are running a SOC, you really need one dashboard from where you can kind of interact with the decoy, and at the same time you can monitor the alert and stuff like that. So, obviously, we wanted to kind of go through a quick journey of how the whole deception journey that Dejavu began with. So we kind of started facing difficulties. Back then we were pen testers in one of the company, myself and Harish, and we kind of questioning whenever we go to the pen test, we kind of one day or the other we kind of get to the domain admin, and regardless of having the traditional and advanced level of security controls, we were able to kind of get to the domain admins of the organizations we were kind of doing pen test. So we kind of started asking this question to ourselves that there has to be some way to kind of prevent this. And that's where basically we started searching around and started forming the shape or you can say the architecture of the Dejavu, and build a first prototype, which was then presented 2018 in Blackhat US, DEF CON and Hack in the Box. Then, based on the feedback that we have got from these amazing conferences and presentations, we kind of improved the platform and made it a standalone platform in 2019, where in a single pane of glass, you have all the capabilities to manage decoys. We added more industry standard, more industry specific decoys like SCADA decoys or banking specific decoys. We started adding. And now here in 2021, I think we have kind of jumped many steps forward compared to what we were back then in 2019. Now we have the cloud-based architecture, which supports, the industry's go cloud strategy. We have now AWS decoys available, which can be kind of used to protect the AWS infrastructure. We have kind of now we are also supporting a possibility to generate your own personalized threat intelligence out of this open source platform, which can be further integrated with your, security operations to kind of give you a very early indications of any potential campaign or any potential attack happening inside the network. And as I said, most importantly, we have also added the full forensic capabilities, and many more feature set has been added in 2021. So that's how we kind of started with R&D in 2018, and this is where we are today in 2021. Now, if I talk about the current architecture, because it is very important to kind of understand the architecture of the solution, so that we can kind of maximize the time and effort that we will put in, or you probably will put
Badrish, sorry to interrupt you. One thing I'll add here is I still remember in 2018, Badrish walked me. I mean, we were sitting in a coffee shop, and he walked with a laptop with I think the first version of Deja, which was a command and console, which was like a bash script, and I think from there to I think today it's significant progress. But I think the core architecture was there back then.
True. And I think that is what we always made sure that, we kind of constantly evolve, constantly hear the feedback and improve onto the platform, and take the community support to kind of offer something which is, worth putting an effort into as a community. So now jumping on to the another important kind of aspect of this whole presentation is to understand, or to reveal rather, to reveal the new architecture which kind of supports the Go Cloud strategy of the organization. So you can see that this is like a very typical, a very high level diagram of an organization. You can see that there is a corporate HQ, and there is a branch office, and there is an AWS network. So what you can do here is that you can use Dejavu engine, and you can place the Dejavu engine in different geographic location or different network segments. So now it is the Dejavu engine and Dejavu console. We'll go through that in our subsequent slides, but here to understand, there are two components primarily. One is Dejavu engine, and another is a Dejavu console. So Dejavu engine is nothing but basically this is where the attacker is going to interact. And Dejavu console is a dashboard where an analyst is going to receive all the alerts in a very simple terms, if I put. So what you need to do in this architecture, what we are trying to highlight is that, let's say if you have a corporate HQ, you can put one Dejavu engine there. You have branch office, you can put another Dejavu engine, and you have AWS network, you have a cloud engine in the AWS network. Now, all these engines basically reports back to the Dejavu console on a centralized location, which kind of supports the MSSP / the cloud, Go Cloud strategy of many organizations that kind of really want to scale the Dejavu or the deception across their infrastructure, across their branches, and across their cloud offerings. So now having that clarity that now there are, like two components, primarily engine and console, we will jump into the different attack scenarios and see how we can use this new version of Dejavu to protect some of the very vital cyber attacks out there. So I think let's start with the first one. The first, I guess, the most notorious and most successful out there attack vector is the spear phishing attack.
Badresh, probably I'll just do a quick intro on the platform and then we could jump into the attack, like just
Sure.
show around the
Sure.
platforms. Yeah. So yeah, like Badresh mentioned in the architecture, there are two main components. One is the engine, and other is the console. Um, Both are basically um, um, virtual platforms. So going back to it, now let me log into the console. So this is what Badrish was mentioning, that all the logs end up in your console and your engine is actually used to deploy the decoys. So using the engine, you could deploy server decoys, client decoys, and then you could manage all the decoys here. And the way the engine communicates with the console is basically using an API key. So you specify the API key to authenticate with the console, and you will provide the console's IP. That's how the connection is established between the two. And any event on the decoy would end up on your console. So you could see all the, you could see this was, we were doing some testing prior to the talk. So these were some of the attacks on the decoys. You could view it graphically as well. Probably once we're doing the demo, you could see, we'll drill down into how do we use the different tabs here. I mean, what does raw logs mean? What does an attack mean? And what does the graph mean? We'll get a better context while doing probably the demo of the attack. Yeah, probably we could start with the attack now.
Perfect. So this is basically from here the fun part starts. So what we have here is that we have one of the most, as I say, like one of the most dangerous attack vector and one of the most successful attack vector out there. which is kind of a spear phishing attack. So we all know like how the spear phishing attack works. So basically, an attacker go after your social media profiles, do a recon, uh, which is could be like your company profile, your personal profile, and try to kind of identify your emails and then drop an email. Let's say if you're an organization, they probably will go to your company's LinkedIn profile, identify all the users working in that company, add the first name dot last name, add your company.com, and that's all they need actually as the primary ingredient to target your users. Uh, so once an attacker has this email address, he will draft a phishing or spear phishing email and send it to your target. The target will open and probably, if not cyber aware, probably will open the attachment, run the macro, and get infected. Or if it is a phishing page, send out username and password to the attacker on the phishing page, etc., etc. So this is a typical spear phishing attack. But now let's see how we can use deception to kind of make it difficult for an attacker to get into your network and at the same time give you a very early warning of something going wrong inside your, for against your organization. What typically we propose here as a defense is that the attacker obviously will do a recon, and in the recon, what we propose is that an attack you kind of create the fail profiles of the users and keep the fail LinkedIn profiles, keep and fake mailboxes on your organization side. So obviously an attacker doesn't know these are fake profiles, will try to phish them also. And on organization side, you have to keep an eye on this fake mailboxes. If anybody tries to deliver any email there, these are the potential phishing emails that you probably would like to investigate. So this is the proposed defense mechanism against this spear phishing attack using the deception. Now let's see how you can achieve this defense mechanism using the Dejavu platform. Harish, probably you can take it from here.
Yeah, let me probably walk through the scenario. So for this example, what we've done is we've made a fake email box called joe.acme909. So this would typically be, I mean, what you would do is you would create a fake email box in your organization as well, and then you will take this email address and now publish it, like Badresh mentioned, in LinkedIn and other places. And now what an attacker would do is, hey, he sees, hey, this is a potential email. Probably he's an IT engineer, or he's a help desk guy, or he's probably in the finance department. Whatever, you could create a fake profile for him, and the attacker is like, hey, this could be a good um, person to send an email out to. So what we would do is on our platform, um, create a client decoy um, called Joe decoy email. Let's say the location is Gmail, and we would configure the IMAP settings here for uh, for this email, right? So that would be imap.gmail.com, the port number, the username, and the password of the email account. I'm not going to do it now. I've already done it. But what would happen is once you create this decoy, um, in the backend, what's going to happen is we're going to constantly monitor this email, and if um, any email hits our decoy email account, that will raise an alert. So this is how the client decoy is set. And now let's probably test by sending an email. I'm just sending an email to myself, but this would probably be an attacker sending an email. So let's say phishing attack, and it's probably something like a login page, right? So this email is now sent, let's say, to this account. What's going to happen is we're going to constantly monitor this, and if we give it a few minutes, we should see the attack on the console. Um, let's give it a couple of minutes and we should see the email here.
So basically, what we are so what this particular decoy is going to do is what Harish has mentioned. It constantly keep an eye on this particular mailbox. So whatever, and there is no limit on how many email decoys you can create. You can create n number of fake mailboxes, and you can create n number of email decoys to kind of constantly monitor these mailboxes on your behalf. So whenever an email, typically since these are fake people, they are not supposed to receive any emails. But if they do, this is where you probably would need to basically, start investigating like who is sending these emails. It could be marketing emails, or it could be a potential phishing email. Obviously, what you can do later is that in this particular email, what is going to happen when an email is received, you will also receive an email as an attachment. So whatever the email that you have received on that mailbox, you can see here that the email which was sent to that particular fake mailbox has been kind of identified, and it generated an event on the deception platform saying that somebody has sent a email to this particular mailbox where nobody is supposed to interact. The next, what you can do with your existing security controls, or if you have like a source out of a tool, you can kind of download this email. So you can click on that particular that small envelope icon. It will basically download the copy of the email which was received, and you can kind of take it to your sandbox, to your SOAR, and kind of investigate further automatically and take the required actions. So yeah, this is how kind of an email decoy works. And if you go to the graphs, so probably if your SOC engineer is constantly looking at this graph, what is going to happen is that another kind of an icon, which is like, it shows that there is an attacker which is kind of targeting the Joe decoy email, and the group where this particular demo was Gmail. So this kind of give you very user-friendly interface to constantly monitor any kind of event which is kind of probably will occur. And it's easy to kind of track the event on this instead of keeping an eye onto the horizontal kind of tabular lines. And most importantly here, if you click on that attacker, it will also give you a little bit of information about what exactly has happened. So what this attacker is, what is the the time when the attacker happened, the kind of the little bit of description, and if you click on the link to the attacker, it will take you it will take you to all the events associated with this attacker. So it kind of give you a very like an umbrella view of what this attacker is up to. That's pretty much it about the email decoy. So what we have seen is that what is the most successful attack vector, how you can use deception to prevent organization from this attack vector, and then how you can use this how you can use Dejavu to kind of articulate or to kind of facilitate this defense mechanism inside your organization. So the next one we wanted to kind of cover as part of this particular kind of presentation was the credential stuffing. So as we all know, again, we'll follow the same kind of phases. We'll try to understand what the attack, or what exactly is the attack, how you can use deception, and then we'll see how you can use Dejavu to kind of articulate this hypothesis inside your network. So the credential stuffing, basically what happens is that the attacker will kind of keep an eye onto the data leaks and compromise accounts. And he will kind of, once he find out certain data leak or the dumps where your organization email addresses and passwords are found, he will kind of go and use this against the published services over the internet. So like here, for an example, a typical organization will have, let's say, a webmail, VDI or VPN exposed over the internet. So what the attacker is typically going to do is that once he found this compromised credential, he's going to use this credential against your published services. And once he is able to successfully compromise one of the services using this valid set of credentials, then he will try to kind of laterally move, use that as his initial foothold, and then kind of try to laterally move inside the organization. This is how the typical, the credential stuffing, the attack works. Now let's see how we can any what is a defense against this kind of attack, and how you leverage the deception as a technology to kind of prevent or make it difficult for an attacker to carry out this attack without getting detected. So here, what our proposal is that we create the fake. You can say this orange boxes are actually the decoys, the fake web service decoys, and you expose this decoys over the internet. Aside or beside your, the actual real applications that you probably have published inside the organization. And here, if you have noticed, what we kind of strategically would like to do is that you keep the common name like webmail or email at company.com, you assign it to the decoy, while you can put, like, for an example, the local name, like local regional name of an email or a random or.company name, which is very difficult for an attacker to guess the subdomain. You can keep those names for your real service, and you can keep very common name for your decoy services. And then that's it. You, from your side, exactly, like that's all you need to do, and then wait for somebody to try to authenticate on these decoys. Because as soon as somebody, a real user of your organization, they already know that the decoy, the real services subnet, they already are aware about those names, so they shouldn't be touching the decoys. But the attacker doesn't know that. So while he do the recon, he will find out these common subdomains, and he will try to enumerate, and he will touch these decoys, which are kind of an early indication of any recon activity getting performed, or any kind of credential stuffing activity getting performed inside our organization. So typically, especially for this credential stuffing, what is going to happen? An attacker having a hands-on compromised credential, he will kind of do a recon, say, okay, tell me what are the services exposed over the internet for this organization. And most commonly, he will find the webmail and vpn.company.com. Or he may find one of the real service. But then what he's going to do, he's going to kind of authenticate onto the services. And he will accidentally also authenticate onto the webmail .company.com, which is nothing but our decoy. And that gives you a high accuracy alert that one of your valid credential has been compromised, and you can kind of do the incident response accordingly. So now let's see how we can kind of convert this hypothesis into the practical using the Dejavu deception platform.
Cool.
Yeah.
So let's probably walk through this scenario, right? So for this, you would typically use server decoys, and what you would do in the server decoy is you would add something like an OVA decoy. So an OVA login page. So and the good thing about OVA would be, or let me create the decoy. So let's call it OVA server 10. Let's keep it on DMZ, and let's start the decoy. So in the backend now, a container is spinning up with an OVA profile, and what you would do is you would map this decoy with a domain name like Bhadresh mentioned, webmail.company.com. And if I open this decoy, it should throw an OAuth page. So this is what an attacker would see, right? And any interaction on this. So let's say he types Bhadresh and he types his password. He's trying different credentials here, right? Um, all of this would be logged in and we can see it on the console. So if I go on the console and look at active attacks, we see activity on this decoy. And if I look at the logs, I know the username and password the attacker has used. Um, and an interesting thing what you could do here is you could take the username and password and actually authenticate against your identity provider and see if it is a valid cred. Because if an attacker actually has a valid cred, now you know the creds are compromised. You could do a password reset and at least stop further prevention. So not only you're able to detect the attack, but also detect if an attacker has active credentials with him, um, which would which through which you could start your IR process. Um, yeah, that's probably the workflow for um,
Yeah.
fake web
I think
servers.
it would be interesting to also mention that you can actually the forensic element that kind of we were talking about. What you can do, you can actually click on that little uh, 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 icon, and you get the PCAP of what exactly happened, and which can be used as like an evidence against the attacker. Uh, So yeah, that's pretty much like 1, 2, 3 clicks, and you have this attack kind of mitigated inside your organization using Dejavu. So the next, yes, correct, yeah. So you can see this is a packet capture, which shows how an attacker, like this is more of like a from the evidences perspective. Like these are the raw evidences which kind of cannot be kind of deflected.
Awesome. So let me stop.
So yeah. So next, the next on the list, let's say for let's consider a scenario where a user, uh, let's say he kind of was not able to, an attacker was, not able to trip the wire on above two recon use cases. Right? He kind of made his way through inside the organization. Without flagging the credential stuffing or without flagging the spear phishing. Let's say consider a scenario where an attacker basically bypassed this about two attack vectors, or he did not use the attack vectors, and he made himself inside the organization. So this is where the third attack vector comes inside, which is mostly like either inside a thread or an attacker who already has compromised one of the user machine. So that attack vector is like most of us, know that this LLMNR poisoning, which is kind of that the responder is one of the most awesome, like an offensive security tool to kind of assess if your network is vulnerable to the LLMNR. But that's, kind of the attack vector wherein an attacker, you can see, having a C2 access on one of the machine inside your network. Then what an attacker is going to do is that he's going to kind of listen the broadcast request and then respond to those broadcasts in the broadcast domain. And what is going to happen is that as soon as the client basically kind of receive this fake response against the broadcast request, and client is trying to connect typically to this attacker controlled machine. And if an attacker requests an authentication, maybe your your client which generated the broadcast would try to authenticate with your domain credential, and that's how you leak your, like your net NTLM or basic credentials type of the authentication that attacker can force in the response. Uh, a client typically will leak the credentials, and that's where an attacker can have more grip inside an organization. So this is how the typical LMNR poisoning attack vector works. Now let's see more details into what we have just explained. If you see what exactly happens inside, because this is important to understand the attack vector to prevent it. So what happens is that the attack user is first going to, or accidentally or misconfiguration through a lookup inside, like this, inside an organization. Typically in your DNS request, what happens is that you can see the step number 1, where the SMB share, if this is an incorrect or misconfiguration, it will go to the DNS server. The DNS server obviously doesn't know this host, so it will respond that, okay, I don't know what you are talking about. And then out of the box configuration will allow the target to kind of broadcast the request for this particular SMB host. So what is going to happen in the third step is that a potential victim is going to request, okay, who is some server? Does anybody know who is some server? And he will send this into a broadcast domain. An attacker having access to that particular infected machine will respond and say that, yes, I am that guy. I am the some server that you are looking for. Please authenticate to me. Then only I will offer you the services. And with this response, a victim will kind of connect back to that attacker or that infected machine and leak his credential. This is like how the attack, LLMNR attack or poisoning kind of takes effect in an organization. Now, let's see how we can use kind of deception to counter this attack vector. So what we propose is that you should have fake clients. The earlier attack vector was fake service, fake user. Now we are talking about the fake clients. That what you can do, you can actually place fake clients which will generate. And what is the job of these fake clients? Is that these clients will kind of send the dummy request inside the broadcast domain, and in ideal scenarios or in normal scenarios, your real servers or real machines or neighboring machines will never respond to this fake request because they are not those hosts. But an attacker doesn't know that. So attacker assumes that this request is my actually potential victim. So he will try to respond and reveal his identity. So you can see in this diagram, what is going to happen is that this orange box is actually a fake client decoy. Is going to send a fake LLMNR broadcast inside the broadcast domain, and attacker will then respond to those queries which he is not supposed to and leak his identity inside the organization. So let's see a little bit in more detail what exactly on the slide. On the slide, if you take the next slide. Yes. So what happens here is that, as we said, like a client decoy is going to send a broadcast saying who has this some server just like before. An attacker is going to kind of respond saying that I'm that server and give me your authentication, authenticate to me in order to basically serve you. And here, where we kind of have to pay attention is that if you get a response, we know that there is an attacker inside a network. So now let's go and see how we can kind of use Dejavu to kind of facilitate this fake client decoy scenario and prevent the LLMNR poisoning.
Cool, yeah. So for this scenario, we could use one of the client decoys. We have numerous client decoys, but to detect LMNR poisoning, we'll use something called the NBNS client, which um, broadcasts fake requests on the network. So let's call this probably Win10, and let's probably keep it on user VLAN. And let's start this decoy. Okay, looks like the name already exists, so I'll call it Win10, and let's call it probably Joe's machine, and let's keep it on user VLAN. You could also define a custom MAC address if you like to. Let's go ahead and create this decoy. Yep, there we go. The decoy has been created. Now, if we go and run responder, we should see a response from our decoy, the broadcast response. So let's open the Kali machine. It's really small. Hopefully, I can maximize this. So what I'm going to do is I'm going to responder here. So let's run responder with default settings. And while this is happening, basically, like Badresh mentioned, our decoy is sending broadcast traffic on the network, and if the decoy sees a response back, it's going to raise an alert. So these are all the poison answers which are sent from our decoy. And if we go back to our console now, so right now we have 6 alerts, right? There should be a 7th alert. And if we go to the console, there you go. We see an activity on our decoy, Win10 Joe, which was the other decoy. And if you look at the logs, we say that there was an NBNS response, which most likely indicates that a tool like responder was used on the network. So this is pretty interesting because you could detect client-side attacks like, I don't know, poisoning. There are other decoys, but due to just the limitation with time, we are not able to demo it. But you could also detect man-in-the-middle attacks like up poisoning and SSDP attack.
Yeah. So far, let's have a quick summary. So far, what we have seen the attacker doing a recon inside the organization, where how you can prevent using the Dejavu. Then an attacker doing enumeration of the service, or like actively interacting with the external infrastructure, how you can prevent that. Then we saw the initial foothold of the attacker, how you can detect an attacker having an initial foothold inside the organization. Now, next one we want to talk about is that, let's say, for an example, this defense in depth we have not in place, and we kind of skipped it through, or one way or the other, let's say we couldn't get our hands on the attacker during those initial phases. We still have a chance. So now let's talk about another, the attack vector, which obviously an attacker will do after he get his initial foothold is called lateral movement, right? So he will kind of he will go around with his stolen credentials and try to elevate his privileges by doing the lateral movement inside the organization. So as we know, like what happens in the lateral movement, the attacker typically use this credentials that he has and go around inside the organization and see where these credentials are going to work, and then kind of it's cascading effect. So he's going to kind of try to steal more credential using tools like Mimikatz or pass the hash, and whatever the credentials he'll get, he will again try to use them until he reaches to the crown jewel of the organization. Right? That's a typical lateral movement scenario. So now let's see how we can use deception technology to prevent this lateral movement attack vector inside an organization. So what do we do is that we create the fake credentials, or you can create the fake service decoys like an SMB or RDP, and you can spread it across the organization. And when an attacker kind of get his hands onto this fake injected credentials, or you can say honey credentials, and he tries to authenticate this inside your organization, any asset, or he tries to touch any of the service decoy, that's where kind of you get his identity revealed. Now let's see how you can kind of use Dejavu deception to prevent this lateral movement, or you let's say my bad. You can use Dejavu to detect the lateral movement inside your organization.
Cool. Yeah. So one of the things you could do is use the breadcrumbs and create something called a honey hash. What this is um, it's basically a combination of username and password, and you would dump this onto the memory, and that's the reason we call it a honey hash. And um, so let's create a PowerShell script, and I'll open the script probably to go through this. So, so what this script does is it dumps these creds in memory, and you could now use this script and dump these creds across your, let's say, user workstations or servers. And once the attacker uses his credentials, I mean, once he uses Mimikatz or dumps the else has memory, he would come across his creds. He will most likely find it interesting and try to see what access these creds have. The moment he uses credentials, because we know it's a honey hash, we're going to monitor it for failed logins, and these creds will have no real value on the network. But the moment he tries to use it, that'll flag a high accuracy alert. And we found this really useful in in a lot of environments where we deployed this.
Yeah. So this is a pretty very like a simple but very solid way to kind of get the attacker from his neck inside the organization, trying to do a lateral movement. In addition to this fake credentials, we can also create the fake services. Like inside the across the organization, you can spread it across the organization. So if he either you probably would catch the attacker using the free credentials or trying to interact with the fake services. And that's where he reveals his identity. Uh, yeah, these are the kind of different sort of services we have so far inside the Dejavu platform, which you can use. If you go to the web server, we have different type of web server. We have Tomcat, we have Apache, we have basic authentication, we have like fake OA, F5 web. If you want to have your own custom web server, you can do it pretty easily. We have like two type of SSH. You have non-interactive SSH. You have interactive SSH. Then you have the RDP. So there are pretty much, I think most common in the RDP also we have interactive and non-interactive. So like this, pretty much these we try to cover all the services that typical organization would have, which includes like some of the ICS kind of decoys also. So yeah, as like what we have just highlighted that you can either use pick credentials or pick services to kind of get the high accuracy alert while an attacker does the lateral movement inside the organization. Now, let's consider a scenario again that let's say attacker tried to do this, but we couldn't catch it somehow one way or the other because of the limitation in people, process, or technology. We couldn't catch it, let's say. And then what an attacker typically is going to do, he is going to start doing the data exfiltration. Now, let's see how we can use deception to kind of identify the data exfiltration activity inside the organization. So that's like like the Maitre attack framework. Like if you cannot catch him in the first phase, then try to catch him in any of the phases inside in the Maitre framework. So now let's talk about the data exfiltration. So typically, as we know, what data exfiltration is that an attacker basically get hands-on to the confidential or sensitive information, and then he leak the information outside the organization, exfiltrate the information outside the organization, and kind of misuse this information. So how we can use deception to kind of use as a defense against this this kind of attack vector. So what you typically can do is that you can create the fake documents. This we call it like the breadcrumbs, fake PDF, fake Word documents, and spread it across your shares, network share or file share. And just wait for somebody. And what this decoy files generally do is that when somebody tries to open it, it will beacon back to the Dejavu console and says that somebody just tried to open the document which nobody is supposed to open, because these are fake documents. Nobody is supposed to open them, and that's how the attacker or the malicious user reveal his identity. In this attack vector. So here we kind of spread the fake documents, you can see, and then an attacker exfiltrate the documents outside the organization. It reaches outside the organization, and when an attacker tries to open that document, that, as I said, like it's beacon documents, it will reach out to the console and save, and that kind of give you an indication that somebody just try to leak the data outside of your organization, and then you can do your incident response forensic to identify who leaked it and how it has happened. So this is a good way to kind of identify the data exfiltration inside the organization. So now let's see how you can do it in the Dejavu platform.
Sure, yeah. I think, Badresh, would it be a good idea to show
is that we will club the demo for the attack vector 5 and attack vector 6 once we finish this AWS explanation. So basically, typically what happens in the AWS attack is that there are two main attack vectors in AWS as per our understanding. First is the stolen credentials. So typically, AWS, we manage the AWS infrastructure and AWS services using the access keys. So an attacker, kind of compromise or steal one of these access keys and then impersonate the user and do, misuse the privilege of this stolen access keys. That's the one attack vector. Another attack vector is that, let's say, one of your EC2 instance is compromised, and then attacker use this EC2 as the initial foothold inside your AWS infrastructure and with the lateral movement. Let's see how we can use the deception to identify and to an extent prevent this attack in your AWS infrastructure. So for the keys, what we can do is that we can create the fake IAM keys and then deploy it across the infrastructure, and then keep an eye on any usage of these fake IAM keys. That's kind of a breadcrumb we can use to identify any potential compromised machine where an attacker got the IAM keys from. Another attack vector, like of the infected EC2 instance, what we can do, we can actually create the fake EC2 instances, like, or you can say EC2 decoys, and spread it in across the AWS infrastructure. And whenever an attacker having the access to the compromised EC2 try to reach any of these fake EC2 instance decoys, will again flag a very high accuracy alert. Now let's see how we can kind of use Dejavu to orchestrate these AWS attack prevention.
Awesome. So I think one of the components which we mentioned in the architecture was the cloud engine, right? So using the cloud engine, you could deploy the AWS decoys. So that's what I'm going to log in into. So let's start with, I mean, looking at the cloud engine. Um, if you look at the architecture, there was a piece for cloud engine. Um, and this service is independent, so you could create an account on cloudengine.camelab.io and start using it to deploy decoys on AWS infrastructure. Let me log in into my account quickly. And let's get the OTP, and we should be good to go. So we are now on the Cloud Engine dashboard. Um, so you could do multiple things here. So let's take it one by one. Badrij discussed about fake EC2 keys. So I'm going to start with that. And the way you would deploy fake EC2 keys is using the breadcrumb section. Um, you could go to Honey Files and say, hey, get me some fake AWS keys. And the way this works is we create a fake AWS key on our infrastructure, so it has no dependence on your AWS in any way. And you could go ahead and deploy this on an engineer's laptop. So let's say um, HDOS engineering laptop, and you create the key. Now, when this key is used by an attacker, an alert would be flagged on the cloud engine. This is how the key would look like. You would have an access key and a secret key, which you would now go and spread across your engineering workstations. What you could also do is programmatically deploy one key for every engineering laptop or user. What would what that would enable is when you have a compromise, you could pinpoint and say, hey, a particular um user's laptop was compromised, because you would know which key was used by the attacker. And I want to reiterate it by saying that this key has no significance to your infrastructure, so you have no risk in any sense. And if an attacker uses this key, it would raise an alert. The other interesting decoy for AWS is to create a EC2 decoy on your AWS account. And the way you would do it is using the cloud decoy management section. You could go to add AWS, add AWS AMI decoys. And once you click on this, it would um, take us to the AMI page, and you could go ahead and launch the decoy in the region and in the um, and with the settings you would like to do it. So I have gone ahead and done this just to save time. So this is the decoy which we've configured. Um, and one thing you need to do is you need to you need to set a rule to enable access from port 65,000. So we've gone and done this to configure the decoy. You could restrict the source to a particular IP here. So let's go ahead and configure the decoy, and the steps for this is mentioned here. So first you would go ahead and use the AMI to deploy the EC2 instance, and then you would connect to the EC2 instance over port 65,000. So there are multiple things here. Let's go ahead and activate the AMI. Let's fetch in the username. And the OTP to connect. So the username would be my username, and let's key in the OTP. So this is the same username and the OTP which you would use to log in into the console. Awesome. So our AMI is successfully registered. Basically, what this means is now any activity on this EC2 instance would raise an alert on our engine. So let's go ahead and configure this before that. Let's call this a web server 10. Let's keep it on, let's say, DMZ VPC, and you could either make it internal or external, and we could then publish whichever services we want. We could have SSH, web server. This is very similar to our traditional way of deploying decoys. And once you go ahead and submit, our EC2 decoy would be configured with these services, and an interaction on any of these services would raise an alert. And that was mainly focused on AWS, right? You could either create an EC2 decoy, or you could create fake AWS keys. Another thing which Badresh talked about was honey docs. I think that's very interesting as well. This isn't specific to AWS, but in general, what you could do is you could create fake honey docs, and if any of these docs are open, it would raise an alert. So what you would do is, let's say you create an Excel honey file and call it financial report 2021, and you would create this doc, and now you would go ahead and place this on the CFO's laptop. If an attacker gained access to CFO's machine, he would most likely open this, and you would see an event here. I guess that's pretty much everything we wanted to cover. I mean, we have a lot more to cover in general. Like, there are different kinds of breadcrumbs, um, both on Cloud Engine and on premise. It was just that we had limited time and we couldn't cover all of it. Um, yeah, Badresh, is there anything else you want to cover here?
No, I think Harish, you covered everything very well. So yeah, I mean, this is what basically the new Dejavu plus plus version has
brought us on the table. And we expect, we really expect and welcome your feedback. You give it a shot and let us know, your feedback. If you want to contribute, the GitHub is up. I would request Harish to kind of put the GitHub link also on the slide so that you can try it, you can contribute it, and share the project. Thank you very much. Please feel free to reach us if you have any questions, comments, or suggestions. Thank you.